So this is the seventh lecture for Chapter 8, which is focusing on water. In the previous lecture, I introduced the concepts of acids and bases. We're going to expand on that discussion in this lecture, looking at the ion product in water and the pH scale, which is this scale that we can use to look at how acidic or how basic a solution is. In the previous lecture, we defined an acid as a compound that produces H plus, or the hydrogen ion, in water, and a base is a solution that produces the hydroxide ion, that OH minus. It's not this simple when we start actually looking at solutions, and that is because when you have pure water, you always have some H plus and some OH minus in that water. That water dissociates slightly to form H plus and OH minus. And as a result, both acidic and basic solutions both contain hydrogen ions and hydroxide ions. So a better way to look at it is that an acid contains a higher concentration of the H plus, the hydrogen ion, compared to the hydroxide OH minus. On the flip side, a basic solution or a base has a higher concentration of OH minus, the hydroxide ion, compared to H plus. And we also can have neutral solutions. In a neutral solution, you have an equal amount of H plus and OH minus. The ion product constant of water, known as the Kw, relates the concentration of H plus and OH minus in water, or in any solution that has water as your solvent. So if you know your H plus concentration, you can always determine your OH minus and vice versa. So the concentration of H plus times the concentration of OH minus is always going to equal 1 times 10 to the minus 14. This constant is based on a temperature of 25 degrees Celsius, but for our discussions, this is the number that we will always use. The variability in this number is very small in the range of temperatures we would find under normal conditions. Again, Kw is known as the ion product constant. And we can use this ion product constant to determine our H plus and OH minus concentration in water. In a neutral solution, our H plus and our OH minus are equal. And in that case, you have a concentration of both of them that is 1 times 10 to the minus 7 molar. These are all molar concentrations. So another way that we look at the acidity or basicity of a solution is using a pH scale. You've probably heard of the term pH. A solution that has a low pH is acidic, something that has a high pH is basic. So what is pH? pH is just equal to the negative log of the hydrogen ion concentration in water. So if you have your hydrogen ion concentration, you take the negative log of that, you get the pH. So an example here, if your H plus, your hydrogen ion concentration is 1.0 times 10 to the minus 3 molar, your pH is going to be equal to your negative log of the 1.0 times 10 to the minus 3, or it's going to be equal to 3. So your pH of that solution would be 3. Since the pH scale is log-based, 1 unit change in pH is a change in hydrogen ion concentration of a factor of 10. So for example, a solution that is pH 2 has 10 times more H plus than a solution that has a pH of 3. So small changes in pH actually can be fairly significant changes in the H plus concentration. I put a note here to look at Appendix 3. If you are having any problems with doing log calculations, this is reviewed in the appendix of your textbook. So again, now let's take a little closer look or more detailed look of the pH scale, and relate that to our ion product in water. So remember, if we know our concentration of one of these species, we can determine the other. So if you are given the pH, you can determine your H plus concentration. From that, you can determine your OH minus concentration. When we look at the pH scale, we said that when you have H plus equal to your OH minus concentration, that is a neutral solution. A neutral solution has a pH of 7. Your H plus concentration is 1.0 times 10 to the minus 7. Your hydroxide is 1.0 times 10 to the minus 7. If your H plus is greater than your OH minus, you have an acidic solution. This has a pH less than 7. If you have a basic solution, your pH is greater than 7. Your hydroxide ion is higher concentration than H plus. So as your H plus pH, this figure just shows some pH values of some common solutions. Again, if you have pure water, nothing dissolved in it, your H plus and OH minus concentrations are the same. This is a pH of 7. We've talked about acid rain in this class. Normal rain has a pH slightly greater than 5. If you start adding in acidic compounds, our NOx, our sulfur dioxide that we've talked about, you are increasing your H plus concentration, you're decreasing your pH. So that's where we get that acidic rain. When we start talking about something like seawater, this has a pH greater than 7. This is a basic solution.